And welcome back to Gaffy's Grinds. We've previously looked at this situation here where we can take flour, add it with eggs, add it with sugar, and we can turn it into a new substance. Nice, yummy cake. Now, in science, we like to keep track of changes that are happening, and we can do that by writing it out like this. We write flour plus eggs plus sugar, and then we would use an arrow like this to show that these things are reacting together to make cake, or in other words, they're turning into cake. So what this arrow means here, this arrow means reacts to make. That's what that means. Okay, and together, this thing here that we've just written out here in black, this is what we call a word equation. A word equation. So scientists use word equations like this so that we can keep track of what's going on during a chemical reaction. We can keep track of what we're adding in, and we can keep track of what we're producing. Now, I want to show you how we can kind of divide this into two halves. So you see the way I'm drawing a kind of an arrow, or a dashed line that goes down through the middle of the arrow. And this splits this into a left side and a right side. And every chemical reaction will have a left side and a right side. It will be on the left and the right of the arrow like this. And what this does is it separates the things on the left are the things that were there in the beginning, the things we put in at the start of the reaction. And then the things on the right, these are the things we produced by the time we got to the end of the reaction. These are what we have at the end. So scientists use a word for these things on the left here. These are the things we start with. So in this case, it would be the flour, the eggs, and the sugar. Scientists call these things the reactants. The reactants in a reaction. Okay, so these are the things we began the reaction with. These are the reactants. And then they call the thing on the right here, what we have at the end, they call these things the products. And the reason why they're called the products is it's got the word produce in it, produce. And obviously things that get produced are things that get made. So the products are the things that get made in the chemical reaction. Now, you see the way in this particular example, I have three reactants. I have number one, I have number two, and I have number three. Well, I just want to show you that it doesn't always have to be like this. Sometimes we might have only one reactant, sometimes we might have two, sometimes we might have three, and sometimes we might have more. And just like in the same situation, in the product here, we only have one product in this particular example, but it won't always be like that. I could have one, I could have two, I could have three. So it doesn't always have to be three things making one thing. And we're going to see that in a second when we look at another example. Okay. Now, I just want to show you what some people, so we're going to look at a second word equation in a second. I just want to show you one of the very common mistakes that a lot of people make when they're writing word equations, because I don't want you guys to make the same one, okay? So here we have the same picture again, the same three things. And I want to show you what some people would do wrong that I don't want you guys to make this mistake. So they would write flour plus eggs plus sugar, and they would say that those things equal cake. I'm just going to zoom out for a second, and I want you to compare the two side by side. Okay, I hope you can see this. I know the writing's got small. They look exactly the same, except this one on the right here has an equal sign, and this one on the left here has an arrow. Go and zoom back in here for a second. I kind of understand why people do this. They do this because this thing is called an equation, and students are used to seeing equations in maths. And when they see an equation in maths, equations in maths always have an equal sign. So I kind of understand why students do this and they make this mistake. However, think about what you're saying here. You're saying that if I took flour, eggs, and sugar, and I put them in a bowl, and I mix them together, that automatically equals the cake. Now, I don't know about you, but if I just mix them three things, flour, eggs, and sugar, threw them in a bowl, mix them up, that wouldn't be something that I would be interested in eating. That is just a big sticky mess. Okay. So they are not automatically equal to cake. If you want to make a cake, what you have to do is you have to take that mixture, put it into a dish, and then you have to put it into the oven and you have to warm it up. And that process of putting it in the oven and warming it up, that causes these things to turn into cake. So the chemical reaction happens in the oven, and that's what makes them turn into cake. So just putting them together, flour plus eggs plus sugar, does not equal cake. You have to do a chemical reaction, and that means that they have to react to make cake. So that's why an arrow is better than an equal sign. So in all the word equations that you guys write, your teacher is never going to want to see an equal sign. They're always going to want to see an arrow. Otherwise, it's wrong. Okay, so hopefully that is pretty clear now, that we always want to use an arrow and not an equal sign. And that arrow means reacts to make. All right, let's have a look at another example now. Okay, so this time we're going to switch to using proper chemical names. And again, we're going to look at chemical reaction that I've shown you guys in class. If you're not in my class, then maybe your teacher has shown you this one. I hope that they have. And it involves taking a liquid, putting it in a test tube. So this particular piece of equipment here is called a test tube. It's just a long, thin piece of glass that holds liquids. And we're putting a liquid in here, and that liquid is called hydrochloric acid. Hydrochloric acid. Okay, and then what we're going to do is we're going to drop in this little thin strip of metal. So this is a shiny, silvery strip of metal, and it's called magnesium metal. So in this reaction, I am adding together magnesium and hydrochloric acid. That's all I'm after doing. And what you see when we did this, what we saw or what we observed in class is we saw lots of little bubbles, fizzing gas being produced. So the bubbles, this fizzing, is telling us that a gas is being produced, fizzing. And the gas then is going to evaporate and is going to collect in the tube here. So again, this is one of our pieces of evidence that a chemical reaction is taking place. We're mixing together a shiny solid, and we're mixing together a colorless liquid. So that's hydrochloric acid is a colorless liquid. And then out of nowhere, we're getting this fizzing, which tells us a new substance is being made, because a gas is being made just by mixing together a solid metal and a liquid acid. Okay, so it has to be a new substance, because I'm not boiling the liquid, I'm not boiling the water, I'm not boiling the acid to turn it into a gas. I'm getting a gas just because I mixed them together. So there has to be a new substance, right? All right. So again, what we're going to do is we're going to do what scientists use. We're going to use a word equation to show what's going on here. Okay. So what we're adding together, this is again what we're going to put at the start here. These are the things we began the reaction with. I began with magnesium. That was the metal. Plus I added it with the liquid, the colorless liquid. It was called hydrochloric acid. Okay, so they're the two things which I put in at the start, and that's why I write them first. And what happened in the reaction is they reacted to make, which I always want to show with an arrow, reacts to make. And they made two products. Now, in this particular example, we could only see one of them, and that's because this first product that I'm going to tell you about, magnesium chloride, this substance is soluble. So I want you to think about what that means. What does soluble mean? So I want you to speak your answer in your mind in 3, 2, 1. What does soluble mean? Okay, so hopefully you were thinking soluble means it will dissolve. So basically, as soon as it's formed, it dissolves, and that's why we don't see it. Okay, so magnesium chloride is soluble, so we don't see this product getting formed. However, we do see the hydrogen getting formed. Hydrogen. Now, because it's a gas, we often use this little arrow upwards to show this means that it's a gas. So to annotate this and say what this means it's a gas and it's given off. Okay, so that's what that little arrow means. Hydrogen is given off. Okay, all right. So remember here, this is what we call a word equation. Word equation. And it describes what happens in a chemical reaction. Okay, so if I was talking about what we've just done there, we've learned how to write a word equation. That's what we're doing here, learning how to write a word equation. Now remember, I can always divide up the word equation into the left side and the right side, okay? So I want you to think, before I tell you what these two things are called here, the things we started the reaction with, can you remember from earlier? Again, speak your answer in your mind. What do we call these two chemicals? Okay, hopefully you were thinking that these are called the reactants. These are the things at the start. So they're on the left, and they're at the start. That's what reactants are. We put them on the left to do our word equation. These are the things that are there at the start. Right, what do we call these two things then? So you see I'm connecting these two things. These are the things that are on the right and they're there at the end. So again, speaking your answer in your mind, what do we call these? 3, 2, 1. Okay, so I'm hoping that you were thinking of the word products. Products. And why are these the products? These are the products because they're on the right and they're there at the end. That's the things we finish the reaction with. Last question then for you for now is, what does this arrow mean? So again, speaking or answer in your mind, what does this arrow mean? And I want you to actually practice saying it in your mind. Okay, so this arrow means reacts to make. That's what that arrow means. Okay, and it should never be an equal sign because we don't want people to think that they automatically equal. They have to turn into these products. Okay, all right, guys. So what I'm going to do is I'm going to ask you to pause and I'm going to ask you to take this down. This is your little heading. What we're learning about here is how to write a word equation. And the reason why we want to do that is so we can explain what's happening in a chemical reaction. So I'm going to ask you to take down the heading and then take down this example of a word equation with all the little annotations that are put on it. So all the little notes that's important when we're making notes. Okay, so pause the video, do that now. Okay, so you should only be playing if we've taken down the example of how to write a word equation. Right, guys, you guys are going to be doing this one for me now. Okay. All right, so you see here, before we begin, I want you to read this and I want you to answer these two questions in your mind. What are the things we started the reaction with and what are the things we finished the reaction with? Okay, so you should only be playing if you've thought about what are the things we started the reaction with and what are the things we finished the reaction with. Okay, so it tells you everything you need to know in that piece of text. Okay, so hopefully you can see that a student reacts hydrochloric acid with sodium hydroxide. These things are there at the start. And then it says makes sodium chloride and water. These are there at the end. Okay, so once we know that, the rest should be easy. So I want you to pause the video and answer A, B, and C for me. Okay, so you only be playing if you've answered A, B, and C here. Okay, so what we're going to do is we're going to write down, okay, what we start with. We should put this on the left. So hydrochloric acid plus sodium hydroxide. Arrow reacts to make. Now, I'm going to show you another thing that some students do wrong here is I've run out of space here. I don't have enough space to fit this in. So I'm going to put this on the next line. So sodium chloride plus water. Now, technically, there's not anything wrong with this. It just doesn't look very good, all right? Word equations, we want them all to be written on one line. So you need to plan before you start writing it, how do I need to do it so I fit it all in one line? Now, one way that we can do this is we can write the name of something, say hydrochloric acid. We can write this on two lines underneath each other. So hydrochloric acid. And we could write sodium hydroxide like this on two lines underneath each other to get more space. That's one way and we could do it. Or we could just write smaller, but try not to put them on two separate lines. It just doesn't look as good, all right? And the reason is when people read it, they're not sure, is it all one line? Is it all one equation? Or is the next line the start of something new? All right, so we want to try and keep it all on one line. So hydrochloric acid plus sodium hydroxide gives us sodium chloride plus water. Okay, so that's A. If you got that right, well done. I'm going to tick it. Spot on. Okay. Now, next one. It says, which substances are the reactants? Now, I don't mind. You can write this down as a sentence. Something and something are the reactants. Or you can do it the way I've showed you to link them together like this. So I'm going to use two different colors, red and I'm going to use blue. Okay. All right. So the reactants here, what you should have said is it's these first two, hydrochloric acid and sodium hydroxide. These are reactants. So you can put them up here like that, like I have, or you can write hydrochloric acid and sodium hydroxide are the reactants. And then these two things, sodium chloride and water, these are the products. So again, you can write that up here and show it, or you can write a sentence about that down here, C. I don't mind which way you do it, okay? As long as you're very clear and your teacher can understand what you're doing, or maybe your teacher asks you to write the sentences underneath, that's fine, okay? I don't mind what way you do it. I think this way is the tidiest way, but it's completely up to you and your teacher, okay? All right, on to the next one now. So hopefully you got that spot on, you got all that right, and you're ready to do some by yourself now, okay? So I'm going to get you guys to do question 26 and 27. So pause the video and do that now. Again, the first thing you should have done here is you should have identified what was there at the start and what was there at the end, okay? So iron is added to nitric acid. So those were there at the start to make iron nitrate and hydrogen. So these were there at the end. It says write a word equation for this reaction. So the first thing you should have done here is you should have said iron plus nitric acid react to make. So arrow reacts to make iron nitrate plus hydrogen. I'll be very impressed, but I'm not sure that any of you would have remembered hydrogen, like we saw before, was a gas. So we draw a little arrow up to show it's a gas that evaporates. All right. I'll be very impressed if anybody remembered to do that. Okay. But not if not, we stick it in now. And remember, what does that mean? It means it's a gas. Okay. So it says identify the reactants and the products in this reaction. So hopefully what we did is we said that iron and nitric acid are the reactants. And they should have said that iron nitrate and hydrogen are the products. Okay, so that's 26 and 27 done. We're going to do 28 now, guys. We're going to do 28. Okay, so pause the video, do 28, A and B for me. Just do A and B. Okay, so pause the video, 28, A and B. Okay, so hopefully what we did here is we did silver nitrate plus sodium hydroxide, sodium hydroxide, react to make silver hydroxide plus sodium nitrate. Okay. All right, so silver nitrate and sodium hydroxide, again, we have to identify the reactants and the products. These are the reactants. And then the other two, silver hydroxide and sodium nitrate, these are the products, P's. Okay, so you can see I'm making it shorter now. All right, on to part B, on to part C now. It says some of the information about the substances, some below is some information about substances in the reaction. So what I want us to do is I want us to write down the color information about each substance underneath them in brackets. So I'll do the first one for you. So it says here that silver nitrate is a colorless solution. That's what it looks like. So silver nitrate, colorless, means it has no color. It looks like water, colorless solution. So I have the first one done. I want you to pause the video and do the rest. Okay, so hopefully then you have written that sodium chloride is a colorless solution. Silver hydroxide is a brown solid, it says. So this one here, brown solid. And this one here, the sodium nitrate is a colorless solution. Colorless solution. Now, I'm going to read this here. It says, how would you be able to tell from looking at the substances that a chemical reaction is taking place? So what I want you to do is I want you to pause the video and try and answer this now. How would you be able to tell just from looking at these substances that a chemical reaction has taken place? Pause the video and do that now. Okay, so what we would see here, guys, is if we go at the side here, what we would see is in the beginning, we would have mixed together the two reactants. So let's call them, let's say reactant A, which is the silver nitrate, and reactant B, which is the sodium hydroxide. We would have mixed these two together. They would have mixed. So A and, oh, sorry, don't mean to delete the whole thing. Just want to get rid of that line. Okay, so A and B would have reacted And both of these were colorless solutions. So in the beginning, we would have had a colorless solution of the mixture of A and B. However, when the reaction happened, they've now turned into C and D. D, we know, is a colorless solution. Looks just like A and B. So from that, we wouldn't know that anything has changed. However, silver hydroxide is a brown solid, which is floating around in a liquid. So this is C. This is the silver hydroxide. Okay. So now we've got a brown solid floating around in a liquid. Brown. So we've made a brown mixture. We'll say a brown mixture. Okay. And this is an example of a color change. So this is why color changes tell us that chemical reactions have taken place, because sometimes one of the products is a different color to what we started with. So in this case, we're making a new substance. That's why we know it's a new substance, because it's actually a different color, and that's why we actually see a color change. So before, in our last lesson, we learned that a color change is a piece of evidence that tells us that a chemical reaction is taking place. So that's what we were getting at there. How would you be able to tell from looking at the substances involved in a chemical reaction and taking place? We've seen a color change because one of the products is a different color to the reactants that we started with. We started with two colorless solutions and we made a brown solid. So obviously we're going to see that brown solid, we're going to see that color change, and that's going to tell us a chemical reaction is taking place. So in short, what's the answer? We've seen a color change from colorless to brown. Okay. All right. So what we're going to do now is we are going to we're going to pause the video and we're going to finish answering now questions 29 down to 32. Okay, thanks for that, guys. We're going to go through them in class the next day, and we'll chat a little bit more about it then. So today has been how to write a chemical reaction, a reminder of what we were learning. We were learning about word equations. Oh, sorry. Where is it gone? Sorry, we'll go back to the lesson. Where are we yet? All right, so just at the top here, you'll see what I'm reading. We were learning about word equations so we can describe what happens to the substances in chemical reactions. So that's what word equations are for, so that we can keep track of what's going on and we can have a full picture of the actual change that's happening in a chemical reaction. All right, guys, see you in the next lesson.